Here we need to estimate this definite integral, and the basis for our estimate is going to be the trapezoidal rule with 3 subdivisions. Well, for the basis of our approximation is going to be the definition of a definite integral f of x dx, where x goes from a to b, which can be approximated as a sum of f of xk star times delta x, where k goes from 1 to n, and we take a limit as n goes to infinity. And we note that delta x is equal to b minus a over n. In our case, when we use this trapezoidal rule, we have n is equal to 3, we have a is equal to 0, we have b is equal to pi over 2. Therefore, we have delta x is equal to pi over 6. Furthermore, for the trapezoidal rule, f of xk star is actually equal to f of xk minus 1 plus f of xk over 2. This follows from the unit area, which is a trapezius. Let's sketch it. So here we have xk minus 1, here we have xk, this value over here is f of xk minus 1, this value over here is f of xk, and the area of the trapezoidal shape is equal to the mean between the mean of f of xk minus 1 and f of xk times the width of the interval, which is equal to delta x. Of course, delta x is equal to xk minus xk minus 1 for each k. So now that we've shown where the trapezoidal rule comes from, we will make a table in order to use it. We will calculate f of x for each point of the subinterval. Of all subintervals, there are 3 of them in this case. So delta x is pi over 6. The starting point is 0. The next point is pi over 6. Then we have pi over 3. And finally the end of the interval, which is pi over 2. Here we calculate f of x. It's sine squared of x. Sine squared of 0 is 0. Sine of pi over 6 is equal to 1/2, and sine squared of pi over 6 is equal to 1/4. Sine squared of pi over 3 can be easily found as sine of pi over 3 is square root of 3 over 2. And when we square it, we obtain 3/4. Sine of pi over 2 is equal to 1, therefore sine squared is equal to 1 as well. So let's apply the trapezoidal rule. The integral of sine squared x dx, where x goes from 0 to pi over 2, is equal to 1/2 times dx, so dx over 2, multiplied by the sum, where k goes from 1 to 3, of xk minus 1 plus xk. In our case, as we said, delta x is pi over 6, so delta x over 2 is going to be pi over 12. And in this sum, the edge points, their values, their function values, appear only once. So f of 0 appears only once and f of pi over 2 appears only once. But f of pi over 6 and f of pi over 3 appear twice in this expression. So we will have 0, which appears once, 1/4, which appears twice, 3 over 4, which also appears twice, and 1, which appears once. Now we sum this up. This yields number 3, so pi over 12 times 3, which is equal to pi over 4.